The very last piece of cuneiform writing we have, the script that began in mud and reeds nearly 3,000 years before any of us, was an astronomy almanac written in the city of Uruk in the year 79 of the Common Era. 3 millennia of legal contracts, hymns, royal annals, complaints about copper merchants, lullabies, and the last hand that ever shaped a wedge into clay was shaping it for the sky. Before everything else faded, the people of this country wrote down the stars one more time. This is a quiet place to fall asleep and to wake up knowing one small thing you didn't know before. Take a slow breath in and let it out a little longer than you took it in. Let your shoulders fall. Let the lamp in your room, if there is one, sit a little lower. Whatever you carried into this evening, you can set it down here. Tonight, we walk together onto a roof in the city of Babylon in the late summer of about 150 years before Christ. The political world has long since gone elsewhere. The school of astronomers has not. A man with a reed pen is waiting for the first star, and beside him 6 centuries of older tablets wait too. The roof we are standing on is wide and flat, and slightly warm under bare feet even at this hour. The day has gone. The river below is dark, and the long curve of it through the city is more sound now than sight, a soft continuous noise that you can stop listening to as soon as you notice it. Beside us, on a low bench, there is a slab of damp clay no larger than the palms of 2 hands placed together. There is a reed stylus laid across it, freshly cut, its tip squared off and clean. There is a small oil lamp on a stone, its flame steady, and there is a man whose name we will not learn tonight. His title is enough. He is a Tupshara Enema Ana Enlil, a scribe of the omen tablets of the sky. He has been on this roof at this hour more nights than he has been off it. So has his father. So did his father's father. Tonight, like every other night, he will write things down. The position of the moon against the stars, the position of the planets, Jupiter just rising now, Venus already set, the weather, how clear the sky is, how much wind, whether the air smells of rain that will arrive before dawn, the height of the Euphrates at the temple's water gate, and, on the same tablet, in the same hand, on the same line, the day's prices in the city's market, barley, dates, mustard, cress, sesame, wool. You may have to hear that twice. The moon and the price of barley on the same tablet, not as a metaphor, not as a clever juxtaposition, just because both were considered by the men of this school to be the kind of thing one wrote down at night when one was watching carefully. The sky moved, the market moved, the river rose and fell, the day passed, all of it went onto the clay. The astronomers of this city have been doing this for almost 600 years. Let that settle for a moment. The earliest entries we still have were made when the first generation of Persian kings was rising. The last were made a few decades before Christ. Between those 2 points lies an unbroken nightly record. What the sky was doing, what the river was doing, what the price of grain was doing, 600 years of nights. There are gaps where the clay has crumbled. There are gaps where a tablet was lost in a fire or buried under a later wall, but the practice never stopped. Boys studied to do it. Old men retired from doing it. New men came in to take their places. The tablets piled up, season after season, on the shelves of this temple and a few others. The men who wrote them used a quiet name for what they were doing. Nasaru Shagine, regular watching. That phrase is written on the edges of many of the tablets, the way you might write the title of a notebook on its spine. Regular watching, not anything dramatic, just the watch, kept regularly, the way a fire is kept regularly in a hearth. This school does not work for free. The men around this lamp tonight are paid. We have records of the arrangement, temple documents from the assembly of Esagila that list these scribes among the regularly salaried staff. The pay comes partly from the rents of date palm groves that the temple owns along the river. Astronomy in this city is a profession. It has pensions. It has apprenticeships. It has a nameplate, in a sense, that long title, Tupsharu Enuma Anu Enlil, which the scribe will sign at the bottom of the tablet in the morning when his hand has stopped being cold. Now look again at what he is about to write. The position of the moon given against one of the bright stars near the path of the planets. The position of Jupiter given the same way. If there has been an eclipse, exactly when it began, how high it climbed, when it ended. If there has been an unusual sight, a comet, a halo around the moon, a meteor, a strange light on the northern horizon, that too, then in a separate section of the tablet, ruled off with a horizontal line drawn with the back of the stylus. Tonight's market. Barley, one of the staples, the volume of grain that 1 shekel of silver could buy at market today. Dates, mustard used in cooking and medicine, cress, a green leaf, sesame for oil, wool by weight. 6 commodities, always the same 6, recorded in the same order, tablet after tablet, year after year, century after century. It is one of the simplest acts in the long history of science, and one of the most patient. Whatever the sky did tonight, whatever the river did, whatever the market did, write it down. Tomorrow night, do it again. The river itself is also part of the entry. The Euphrates, just beyond the wall, has a water gate marked with cubits, small horizontal grooves cut into the stone. A junior member of the school will have walked down to the gate at dusk, looked at the water against the grooves, and brought the reading back up to the roof. Tonight, perhaps, the river is 2.5 cubits high. Tomorrow it may be slightly higher, in winter much higher. The scribe records it without commentary. A river of a known height, passing through a city of a known place. Lower that goes in next. Clear or north wind or cloudy in the second watch, or rain after midnight, whatever the night gave. There are diary entries that begin with the moon's position and end with the price of mustard, and that mention almost as a footnote an event that other ancient sources record as a turning point in world history, the death of a king, the arrival of a foreign army at the gates, an uprising in the city. The men of this school noted these things in passing. Their primary work was the sky. The world below was context. You can still hold these tablets today. Most of them rest in the British Museum, in long flat drawers, brown and dense and lighter than you might expect. They are catalogued by number. They are read 1 line at a time by a small group of scholars who can untangle the abbreviations and the standard formulas. And here is the part that is, by any quiet measure, remarkable. Those tablets are not only history. When modern astronomers want to know precisely how the Earth has been spinning over the long term, they need eclipse records from much further back than telescopes go. The Earth, very gradually, is slowing down. Its rotation is being softened by tides, by movements in its molten interior, by other small forces. The cumulative drift over centuries is small but measurable, and to measure it, you need eclipses whose exact times and places you know. So when scientists at NASA build their tables of historical eclipses, the ones they use to plot future ones for the next several thousand years, they reach back through the centuries, past the Greeks, past the Persians, past Alexander, and they read these tablets, the diaries of the men on this roof, the barley and the moon on the same line. 6 commodities, 6 centuries of nights, the eclipse that this scribe will not witness tonight, but that an earlier scribe of this same school did witness 2 centuries ago, and recorded with the kind of patient precision he was paid for, will end up, in a roundabout way, helping a satellite plot its orbit. It is hard to say something like that calmly. We will, anyway. The man on the roof beside us would. He is leaning on the parapet now. The first stars have come. The brightest of them, Jupiter, is climbing out of the haze near the horizon. He picks up the reed stylus. He turns the clay to a better angle to catch the lamplight. He begins. He writes from left to right with quick, clean little impressions. 3 wedges here, 4 there. The signs are short forms of full words. Moon position takes only a few strokes. He works steadily, the way someone who has done a thing 10,000 times moves, without hurry, without hesitation, with the kind of small comfort that comes from a routine that has outlasted any one person doing it. When he has finished tonight's skyline, he will draw a short horizontal ruling. Below it he will write tonight's prices. He has not been to the market today. He does not need to. A boy will have come up earlier and given him the figures, the way the boy has given them to the previous watcher, and the one before that, going back further than the boy's grandfather can remember. The numbers will be written in the same hand as the moon, the same ink in a sense, the same lamp. If you were to take this evening's tablet and lay it down beside a tablet from the year of the city's last Babylonian-born king, more than 400 years ago, you would find the same format, the same 6 commodities, the same kind of weather notes, the same kind of sky notes. The handwriting would be different. The clay would be a different clay. But the practice, the rhythm, the order of the lines, the choice of what to write down and what to leave out would be unmistakable. It is the same notebook. The cover keeps changing. The notebook keeps going. This is what we have come up here to begin with. Not a single famous discovery, not a particular night, but the long, quiet fact that this school has been holding a continuous, unhurried watch on the sky and the city for almost 6 centuries, and is still holding it tonight. The lamp burns. The Euphrates makes its low sound. Far below us, in narrower streets, a few late lights still show. A baker's oven being banked for the night. A tavern emptying. None of those things will appear in tonight's entry. The price of bread tomorrow, however, will. The sky above the bread will too. They will be next to each other, in tidy lines, on a slab of clay no larger than 2 hands. Somewhere in the corner of the rooftop, leaning against a low wall, is a small wooden box. Inside are several older tablets, brought up tonight for reference. One of them is from 60 years ago. Another is from many more. They will be opened later in the watch, when there is a question to settle. They will be returned to the box before dawn. The school has many such boxes. They are arranged on shelves in a series of rooms attached to the temple, and they are tended in much the way the lamp on this parapet is tended, calmly, by people who expect to be doing this again tomorrow. And while one tablet still drying carries tonight's barley and Jupiter, another tradition the same school helped write is held above us, much further off, in the band of stars that arcs through the highest part of the sky. Now imagine that band drawn neatly into 12 equal pieces in this city by men very much like the man at the parapet, and imagine the night a few centuries earlier when those 12 pieces were first decided. The man at the parapet has finished his first line for tonight. The clay has taken the impression cleanly. He sets the stylus down across the tablet, the way a musician rests a bow across the strings between phrases, and he looks up. Follow his gaze. The band of stars he is reading is not the whole sky. It is a single narrow ribbon that arcs from the eastern horizon, climbs through the high sky, and falls again toward the west. Along this ribbon, all of the moving lights travel, the moon, the planets, the sun by day. It is the road of the wandering bodies. He reads this ribbon the way a careful reader follows the line of a single sentence across a page, and along that ribbon, in his mind and on his tablets, the sky is divided into exactly 12 boxes, 12 equal boxes, each 30 degrees wide, each named after a creature or a figure that the people of this city once drew in the stars: the hired man, the bull of heaven, the great twins, the crab, the lion, the furrow, the balance, the scorpion, the pabblesag, the goatfish, the great one, and the tails. If those names sound slightly unfamiliar, soften them, slow them in the mouth. Hear the Greek translations that came later, the ones still printed on the side of horoscope columns in modern newspapers. The hired man becomes Aries, the bull of heaven becomes Taurus, the great twins become Gemini, the crab, the lion, the furrow becomes Virgo, the balance becomes Libra, the scorpion, the goatfish becomes Capricorn, the great one becomes Aquarius, the tails become Pisces. 12 creatures arranged in the same order you might still find tonight, on a small printed wheel beside a coffee cup, in a city far from this one, 2,000 years from now. The man at the parapet, however, is not casting a horoscope tonight. He is using these 12 boxes the way a mathematician uses a coordinate grid. When he wants to say where Jupiter is, he does not need to point to a specific star. He needs to say which of the 12 signs Jupiter is currently inside, and how many degrees deep into that sign it has traveled. 8 degrees into the Scorpion, 14 degrees into the Lion. Then anyone else, anywhere in the country, reading the same diary in the morning, can know exactly where Jupiter was tonight. This is a measurement grid. It is one of the quietly important inventions of the city of Babylon. It is also, with very small adjustments, the same grid that anyone alive today who has ever read their horoscope is using. Let that sit beside the lamp for a moment. The 12 equal signs did not exist for most of human history. Earlier Mesopotamian stargazers, the men who came before this school in earlier centuries, did not have a tidy ring of 12. They had perhaps 18 sky figures, uneven, sprawling, some of them long and thin, others crowded together. They named them and watched them, but they could not easily give Jupiter a single number for its position, because Jupiter would sometimes wander into a constellation that was very wide, and sometimes through one that was very narrow. The road of the planets, as a road, did not have neat mile markers. Sometime in the late 5th century before Christ, perhaps 2.5 centuries before this present night, astronomers of this city sat down with this problem. They had a calendar already, 12 months, each 30 days long, 360 days in a schematic year. They had centuries of records of the moon and the planets, and they had a question that, after centuries of patient watching, had ripened. Could the road of the planets be cut into 12 equal pieces, one for each month? It could. They did not invent the figures. The bull, the lion, the scorpion, the twins, these had been drawn on tablets long before. What the late 5th century astronomers did was trim and align them. They took the long ones and shortened them. They took the short ones and stretched them. They overlapped some, set aside others, drew them all to the same scale, and laid them out, one after the other, along the ecliptic, so that each occupied exactly 30 degrees of the celestial circle. 12 neat signs, 12 neat boxes, a measurement grid in the sky. It was, in its essence, an administrative act, a tidying, the kind of decision a careful bureaucracy makes when its records have grown too large to keep without a system. And the system has lasted ever since. The Greeks adopted it later, about 200 years later. By the time of Hipparchus, in the 2nd century before Christ, Greek astronomy had inherited the Babylonian division of the band of planets into 12 equal slices, kept the names in translation, and built outward from there. By the time of Ptolemy, in the 2nd century after Christ, the system was already so settled, so familiar, that it seemed natural. Of course the sky was divided into 12. How else could it be divided? The man at the parapet would shrug gently at the idea that this division ever needed defending. It is for him simply how a tablet is laid out. The moon is in the furrow tonight, past its halfway point. Jupiter is in the Scorpion low. Venus has already set in the balance. He will write all of this down in the standard formulas. The system is older than he is, but not much older than his grandfather's grandfather. Several lifetimes back, his own school decided how it would be done. Now consider the personal horoscope, the thing that, in the modern world, the 12 signs are most associated with. The idea that your character, your fate, your love life, your taste in food, can be read from the position of the sun on the day you were born. That use of the zodiac came along a little later. The earliest Babylonian personal horoscopes we have are from this same Seleucid period. There are perhaps 30 of them surviving. They are small, careful tablets that list, for a particular newborn, where the moon and each planet stood on the day and night of birth. They do not say very much about character. They mostly just record the data. The interpretation, the prose poetry of the modern horoscope would come from the Greeks, from Egyptian Greek astrologers in Alexandria, from medieval Arab compilers, from Renaissance printers, from 20th century magazines. The grid, though, the 12 equal boxes, is from here. It is worth pausing a moment longer on what the older sky figures looked like before the late 5th century men tidied them. There was a great fish that stretched across what we now call the Great Twins and the Crab. There was a long furrow that flowed across what we now call Virgo and a portion of Libra. There was a smaller stretch where the lion now stands, and several minor figures clustered tightly along what is now Sagittarius. The men of this school still keep a few older tablets that show those uneven shapes. The young apprentices are sometimes shown them in their first or second year, so that they can see the older arrangement and feel the difference. The difference is the difference between a path with no mile markers and a path with 12 neatly placed stones. The 12 neatly placed stones made many things possible. A diary entry could now say, with one short phrase, where Jupiter was. The man at the parapet, decades from now, reading this same diary entry, would not need to know which constellations the writer of his own night had been thinking of. The position was given by the grid. The grid was the same as his own. A scribe in this temple could now compute on his wax tablet where Jupiter would be in 3 months. A merchant looking up from a courtyard several streets away, who had been a younger boy in the school and remembered the names, could glance at the sky and know which of the 12 was rising. A traveling visitor from another city, given a copy of one of the school's tables, could find the same star in his own sky and agree with it. The man at the parapet draws a small horizontal ruling on his tablet, just below the moon's position. He will now write the place of Jupiter. He has a junior near the bench, perhaps 15 years old, whose job tonight is to copy out today's commodity prices once the watch settles in. The boy is watching him. He is too young to have written a full diary entry yet. He has written practice tablets, the way every boy in this school has for years now. He will write his first real entry within the next year or two. He will sign his initials very small at the bottom edge of the clay. When the boy is asked, decades later, to point at a star and say where it is, he will point with 2 hands. One hand will sweep along the long ribbon of the planets. The other will mark the place. In the lion, 8 degrees. The grid will be inside him by then. It will feel as natural as the way you, listening tonight, feel the days of the week. Completely artificial, completely yours. While the moon and Jupiter are being placed onto tonight's grid, far below in the city, an old woman who has never sat on a roof reading the sky still knows which sign she was born under. She would name it in the Babylonian form, of course. Perhaps the furrow, perhaps the goatfish. The very same form that will reach you tonight in your own language, with its Latin label on a piece of decorative pottery, on a page of a glossy magazine, in the small print of a dating profile, On a tattoo on the back of someone's shoulder, the label changes. The grid is the same. The grid was laid out by the men in this temple. This is one of the strange small gifts that has come down to you from this city through 24 centuries of intermediaries, a method for cutting the sky into 12 equal pieces, made portable by language, made personal by later cultures, made tonight on this roof by a hand that does not know it is doing anything other than its work. There is a small, almost domestic side to all of this that is worth holding in your mind. The men who decided in the late 5th century to lay the band of planets out in 12 equal pieces were not striking a pose. They did not write a manifesto. They left no founding document. We know what they did from the way later tablets are arranged. We know from the way coordinates are given. We know from the way the older 18-figure system fades out of the diaries during a particular generation, and the 12-figure grid quietly takes its place. Somewhere on this very temple complex, a few decades of nights of conversation between senior astronomers ended with a small decision. The decision then traveled by reading and copying and rereading to the rest of the country, and from there outward, slowly, into every literate culture that touched the Mediterranean and then beyond. A small decision in a small room, a grid that would, much later, end up tattooed on the back of someone's shoulder in a city the men in this room could not have imagined. The lamp burns. The first watch is settling. The man at the parapet has now placed Jupiter on the grid. He has placed the moon. He has placed Venus just before it's set. He is making a small note in the margin, a faint halo possibly, around the moon tonight, depending on whether the haze deepens. He sets the stylus down. He breathes out. Before the night deepens, before the middle watch turns the air cold, let us look at how the man at the parapet actually does his work. The boxes on the sky are only the framework. Behind them is the rhythm of a working night. Picture this rhythm beginning, gently, now. The first watch of the night is, in this city, a particular thing. It begins shortly after the lamps in the houses are lit. It ends, roughly, when the brightest stars have all risen. After it comes the middle watch, the longest and the coldest, when the air on the rooftop changes character and the brazier needs to be tended more carefully. After that, the third watch, the watch that ends with the first paling of the sky in the east. 3 watches. The men in this school call them by an old word, masata, which simply means a watch, a guard, a turn of being awake while others sleep. The night was divided into 3 so that the sky would never be unwatched. We are in the first watch now, and the scribe at the parapet is the senior on duty. He is perhaps 40, perhaps 50, old enough that the school's juniors call him by a title rather than a name, young enough that he still climbs the temple stairs in a single steady motion. He will work until the middle watch arrives, which is about 3 hours from now. Then a younger scribe will come up the stairs with a fresh stylus and a fresh slab of clay, and the 2 of them will exchange a few quiet words at the parapet, what the moon has done so far, whether the wind has shifted, whether Jupiter has crossed the line of one of the brightest stars. The middle watch scribe will then take over. The senior will go down. He may sleep in a small room 1 floor below with his sandals still on for several hours, or he may stay awake sitting in the temple's reading room looking at an older tablet. He has the option. The work is not finished until the third watch is over. On the bench beside him tonight, there are several objects. The slab of damp clay we have already seen, the reed stylus, the lamp, a small brass measuring stick for the spacing of cuneiform lines, a second smaller tablet for rough notes, half erased and reused many times, a folded square of linen for wiping the hands, a clay cup of water, a second clay cup of something thicker, perhaps a thin barley beer, perhaps a hot herb infusion to keep the throat warm, and a wax-covered wooden tablet, the kind you can write on with a metal stylus, smooth the wax down, and write on again. He uses it for arithmetic. He has in fact been using it earlier this evening before we arrived. The numbers he scratched into the wax have already been smoothed away. Now the wax is clean, and he has set the tablet aside. At the very edge of the bench, almost falling off, there is a stack of 3 or 4 other clay tablets. They have been brought up from the temple's archive earlier this evening. The boy fetched them. They are old. One of them is from 60-some years ago, and they have a particular use that we should sit with for a moment. They are called goal year texts. The word goal year sounds modern. The Babylonian name is something more like the texts of the years selected for, but the function is the same. These tablets are working almanacs. They were compiled by a previous generation of this school, perhaps 80 years ago, perhaps 100, and they have a very specific function. They list for each planet the recurrence period after which that planet's pattern of motion repeats. Jupiter has 2 such periods, 71 years, 83 years. After 71 years, Jupiter does almost exactly the same thing it did before. The same risings, the same crossings of the zodiacal boxes, the same retrograde loops. After 83 years, it does the same thing again, more precisely. Saturn has its own period. So does Mars. So does Venus. So does Mercury. The astronomer at the parapet, if he wants to know what Jupiter will do next month, the dates of its first appearance after conjunction with the Sun, the dates of its retrograde loops, the dates of its crossings of the major stars, does not need a model. He does not need to calculate. He needs to know which year 71 years ago corresponds to this year, and then he needs the diary entry from that older year. He looks at what Jupiter did then. He copies it forward. It is a working forecasting almanac, built on the back of more than a century of nightly diaries. The school could anticipate the next year's sky simply by going to the shelf, choosing the right tablet and reading time travel by index card. The astronomer does not call it forecasting. He would not use that word in any dramatic register. He uses words like expected, foreseen, known where to look. The sky is not surprising tonight. Most nights it is not surprising. The school knew where to look. Beside his arithmetic tablet, there is also a small bundle of older notes that he made in his apprenticeship years when he was learning the named cycles. He has them up here partly out of habit. The cycles are now in his head. He could recite the recurrence periods of all 5 planets in a single breath, the way you listening can recite the days of the week. Look at the wax tablet for a moment. The Babylonian wax tablet is a wooden frame, perhaps the size of a small book, with a shallow rectangular well on each side filled with dark wax. The scribe writes with a metal stylus rather than a reed. The metal cuts through the wax cleanly. When he wants to erase, he warms the metal slightly, or simply smooths the wax with the flat side of the stylus, and the writing disappears. He has used this surface earlier this evening for some preliminary arithmetic, goal year periods, position of Jupiter for tomorrow night and the night after that, a small column of figures neatly arranged. He has copied the result to a small note on a separate piece of clay. He has then smoothed the wax. The wax now holds nothing. It is ready for the next problem. The stack of older tablets on the corner of the bench is also a quiet study in itself. Look at it. The clay of the oldest tablet is a slightly different shade of brown than the clay of tonight's tablet. The clay pits the school used 80 years ago were not the same as the clay pits it uses now. The signs on the older tablet are smaller and more compressed. The man who wrote it had a hand that worked very fine. The middle tablet from 60-some years ago is larger and looser. That writer worked in a generous hand. Tonight's clay will be in the middle when it is dry. A steady hand, neither tight nor loose, like the senior himself. The school has in its long memory perhaps 1,000 pairs of hands, each one different, each one trained in the same syllabary, the same standard formulas, the same 6 commodities, each one taught to draw a horizontal ruling with the back of the stylus, just so. The school can hold all of them, the way a riverbed holds water that flowed through last year and water that flows through now. The riverbed is the school, the water is the men. A word about that learning. The boys of this school start young. They begin perhaps at 8 or 9. They learn the cuneiform signs first, the basic syllabary, the names of the gods, the standard formulas. Then they begin to learn the longer omen series. The most important of these, the spine of the school's curriculum, is called Enuma Anu Enlil. It is 70 tablets long. It was compiled in something close to its current form around 1,000 years before this night. It has been copied, recopied, taught, memorized, and refined for more than a millennium, generation after generation. It catalogues the meaning of celestial events, what each kind of eclipse meant, what each kind of planetary conjunction meant, what each kind of cloud halo around the moon meant. The scribe at the parapet learned all 70 tablets, more or less, by the time he was 16. So did every other working astronomer in this temple. The title he wears now, Tupsharu Enuma Anu Enlil, scribe of the Enuma Anu Enlil, comes from this text. He is, by training, a reader of the world's longest continuously taught textbook. It was old when his great-great-grandfather started his apprenticeship, and it will still be on the school's shelves long after this scribe is gone. The boys also learn the practical, sensory side of the work, which is harder to put on a tablet. They learn how to choose a reed for a stylus, the right thickness, the right pliability, the right way to cut the tip square so that the wedge it makes in the clay is clean. They learn how to prepare the clay slabs, how damp the clay should be, how to smooth it without overworking it, how to set it on a slightly tilted surface so that the lamp's light catches the impressions. They learn how to read the older tablets with their slightly different sign forms and slightly different formulas without making mistakes. They learn how to keep a brazier alive through a cold middle watch. They learn eventually how to talk quietly to the next watch's man at the handover without waking anyone in the rooms below. He puts a hand on the side of the brazier briefly to warm it. The first watch is calm so far. The moon has crossed the position he expected. Jupiter is exactly where the goal year text suggested it would be, within a fraction of a degree of the prediction made 83 years ago by a man whose handwriting he now knows by heart. This is the great quiet pleasure of this school. The sky for a senior scribe like this one holds very few surprises. Almost everything he sees tonight he expected to see. The moon's crossings, Jupiter's loops, the dates of probable eclipses for the next year or two, these are all already in the almanac on the bench beside him. The work tonight is not to discover. The work is to record carefully what an old man in this temple a lifetime ago already wrote down, and to add tonight's small additions to the bottom of the shelf for someone 70 years from now to read. The middle watch, when it comes, will bring a younger scribe. The younger one is 23. He has been working alone on the roof for about a year, after 8 years as an apprentice and 2 years as a junior under supervision. The senior, when he hands over, will not say much. He will say, "The moon has crossed the bright star near the bull on time." He will say, "Jupiter is on the line we expected." He will say, "Perhaps tonight, the haze on the eastern horizon is thicker than usual. Watch for the halo." He will say good night. He will go down the stairs. The middle watch scribe will sit at the bench and continue. The lamp will continue. The river will continue. The brazier will need a small handful of charcoal at the deepest part of the cold. The wax tablet will be picked up, written on, smoothed clean again. The clay tablet will be set aside to dry slowly, so that tomorrow it can be cut to a finished shape and stored on a shelf. And while the second watch settles into its rhythm, the man who has just left the parapet sits, before going to sleep, with a tablet from years he himself was not yet born to see. Long before tonight's sky, another night was already written down. Now imagine the moment when the senior astronomer of this same school, several generations earlier, first noticed something about Jupiter's motion that no one had quite put into a picture before. The middle watch has begun. The younger scribe, the 23-year-old, is now at the parapet. He is settled in. He has placed his own slab of clay on the bench. He has the wax tablet to one side, ready for arithmetic. He has the lamp set just so that the light falls on the surface of the clay rather than in his eyes. He has chosen a small additional tablet from the stack the senior left for him, a particular tablet from about 90 years ago that he was told to consult tonight if Jupiter's brightness held steady. This particular tablet, which we will spend some time with now, holds one of the school's quietest discoveries. It does not look like anything special. It is a roughly rectangular slab, the size of a small book, with neat lines of cuneiform on both sides. A modern reader looking at it without context would see only numbers and short phrases arranged in columns. But if you sit with it a while, and if someone explains what the numbers are doing, you discover that the men of this school had worked out something that the rest of the world would not work out in any documented form for another 1400 years. They had worked out how to find the distance Jupiter would travel by treating the planet's speed as a shape. Let that sit for a breath. The astronomers of this school knew, from centuries of diary entries, that Jupiter does not move at a steady speed across the sky. Some weeks it moves quickly, some weeks it slows, some weeks it stops, reverses, and traces a small loop. Then it resumes. They had, by patient work, tabulated this speed. They could say for each day in a 60-day stretch how far Jupiter would move. They could draw in their imagination a graph, time along the bottom, speed on the side, a slanted line connecting the two extremes. If you draw such a line, and you complete the picture with a flat baseline along the time axis, you have a trapezoid, a four-sided figure with two parallel sides, two vertical sides, the starting speed on one end, the slower speed on the other, one slanted top, one flat bottom. Now ask yourself, how far has Jupiter actually traveled over those 60 days? The astronomers of this school answered that question by computing the area of that trapezoid. It is a small sentence. Read it again slowly. They answered the question of how far a planet had moved by computing the area of a shape on an imaginary graph of its speed. That sentence describes, in essence, the technique that medieval European scholars at Oxford and Paris would rediscover in the 14th century. The Oxford calculators, the masters at Merton College, the philosopher Nicole Oresme in Paris. Those names are remembered in the histories of mathematics as the originators of the idea that the distance covered by a moving body is given by the area under its velocity curve, the mean speed theorem, the first hint in European thought of what would later become integral calculus. And here, in this temple, at this hour, the men of this school have been doing the same thing for at least 2 centuries. The tablet on the bench in front of the young scribe is one of perhaps 5 we have today that show this technique clearly. They were reread carefully in modern times by a historian of science named Matthew Osundriver, working at a university in Berlin. He published his careful rereading in the journal Science in the year 2016. Before his work, several of these tablets had been in museum drawers for over a century, with their meaning unclear. Most of them were assumed to be calendrical or astrological. Their geometry was hidden in plain sight. There is a small detective story inside all of this that is worth telling slowly. The 5 tablets had been in the British Museum's collection for over a century. Some of them had been catalogued in the late 1800s when European archaeologists were bringing back wagon loads of clay from Babylonian sites by the river. The tablets sat in shallow wooden drawers in the museum's storerooms, with brief curatorial descriptions, some of them suggesting that the tablets were calendrical, some of them suggesting that the tablets concerned astrology in an unspecified way. They were known to be Babylonian. They were known to be astronomical. The detail of what they actually did was hidden in plain sight. Generation after generation of scholars who knew cuneiform read them, transcribed parts, and moved on. The geometry was not noticed. Ossendriver had spent years reading other Babylonian astronomical tablets, the better understood ones, the ones built on arithmetic. He had grown familiar with the standard formulas, the standard column layouts, the standard ways of presenting a problem when he came across the 5 geometric tablets, one of them only recently identified as belonging to the same set. He recognized in the structure of the text something the previous scholars had not put together. The text was describing a figure. The figure was a trapezoid. The numbers were the dimensions of the trapezoid. The result in the next line was the area of the trapezoid, and the area was being used in the line after that as a distance. What Ossendriver showed, line by line, was this. The tablet computes the area of a figure that the Babylonian text itself describes as a trapezoid. The width of the trapezoid is 60 days. The 2 vertical sides are the speeds of Jupiter at the start and end of those 60 days, given in degrees per day. The area of the trapezoid, width times the average of the 2 heights, in modern terms, is in this context a distance. And then on some of these tablets the astronomers do something even quieter. They ask, at what moment in those 60 days has Jupiter covered exactly half its distance? They answer that question by drawing a vertical line through the trapezoid that splits it into 2 smaller trapezoids of equal area. The line is not at the midpoint of the 60 days because Jupiter is moving more slowly at one end than the other. The line is offset. The astronomers know exactly where. They have, in other words, understood that the area of the figure represents the distance, and they have understood that to bisect the distance you must bisect the area, and they have understood how to find the line that does that bisecting. The young scribe at the parapet learned this technique in his apprenticeship. He could not perhaps give a clean proof of it. The school does not seem to have written out proofs in the Greek manner. What he learned was a procedure. Here is how you set up the trapezoid. Here is how you read the diaries to get the velocities at the 2 ends. Here is how you compute the area. Here is what the area means for the planet. The procedure works. He has used it. He used it earlier this evening, in fact, before we arrived. The numbers on his wax tablet, smoothed away now, were exactly this kind of calculation. The school has, by this period, a small body of teaching tablets that explain how the trapezoid procedure is to be set up. The teaching tablets are kept on a shelf next to the reading room of the temple. They are used to bring younger scribes up to the point where they can apply the procedure themselves without supervision. There are no proofs on those teaching tablets in the sense that a Greek geometer would later use the word. There are instead worked examples. Here is the situation. Here are the velocities at the 2 ends. Here is the trapezoid. Here is the area. Here is what the area means. Then a second worked example. Then a third. By the time a young scribe has copied his way through perhaps a dozen of these worked examples, the procedure is in his hands, the way a song is in the hands of a player who has rehearsed it enough times. It is striking, when you sit with it, how abstract this is. The Greeks, when they did geometry, did it on the real world. Lines on the ground, circles in the sand, triangles between cities. Their figures were figures of physical things. The men of this school drew their trapezoid in a space that does not exist anywhere except in the mind, a space whose horizontal axis is time and whose vertical axis is the speed of a planet. They drew an abstract picture. They asked a question of it. The picture gave back a number that, when applied to the real sky, was correct. This is what some historians of science now call mathematical astronomy, two systems in the Babylonian tradition called in modern shorthand System A and System B. System A treats the speed of the moon and planets as changing in discrete jumps, step functions in modern terms. System B treats the speed as changing smoothly, linearly, up and down across the zodiac, what we would call a zigzag function. The young scribe at the parapet tonight uses both. He chooses depending on the planet. He chooses depending on what he needs to compute. The arithmetic itself, on his wax tablet, looks unfamiliar at first. The Babylonians do not work in tens, they work in 60s. Their numbers are written in a base 60 notation that you have in fact encountered before every time you have said the words 60 minutes or 60 seconds or 360 degrees. Those phrases are a quiet inheritance from this place, brought into your modern day by Greek astronomy and never replaced. We will not pause to make a long thing of it tonight. The men of this school did not think it was worth pausing over. It was simply how numbers were written. What is worth pausing over is the image. Imagine the young scribe leaning a little closer to the lamp. He has drawn a small trapezoid on his wax tablet with the metal stylus. He has labeled one short side with one number and the other short side with another. He has scratched beneath the figure the simple multiplication that gives him the area. He has compared the result to what Jupiter has done in tonight's actual sky. The two numbers agree to a fraction of a degree. There is a small pleasure in this for him that we should sit with for a moment. The pleasure is not the pleasure of discovery. He is not discovering anything tonight. The pleasure is the pleasure of agreement. The tablet says one thing. The sky says the same thing. The two agree in a way they would not agree if any of the long chain of careful work behind the tablet had broken at any link. The diary entries had to have been kept faithfully. The velocities had to have been read correctly. The trapezoid had to have been set up properly. The arithmetic had to have been done without slips. The sky itself had to have continued behaving the way the sky behaves. And, given all of that, the result on the wax tablet matches the planet in the sky. It is the small pleasure that any working scientist or working craftsman knows. The tools work. The tools are the right tools. The work that has been put into the tools across centuries is honored tonight by one more small calculation that agrees with reality. He permits himself, very briefly, the small, slow smile of a man whose tools work. The sky moves on. He looks up, marks tonight's position of Jupiter on his clay diary tablet, writes a brief sentence about the haze on the horizon, and sets the stylus down. The wax trapezoid is smoothed away. The clay diary is left to dry. The shape that holds the distance of Jupiter has done its quiet work for tonight. And while one tablet drying on the bench holds Jupiter's calm trapezoid, another lies further along, a smaller separate tablet that the chief astronomer keeps to one side, and that is reached for only on certain rare nights. Far across the bench from the lamp, a different kind of work is sometimes done. Once a year, sometimes twice, the chief astronomer of this school takes a particular kind of tablet down from a shelf in a particular kind of room. The room is small, the shelf is plain. The tablet is no different in size from a market prices tablet or a goal year text, but it is kept apart, and it is used only on certain nights, and the way it is handled is quieter than usual. We will sit with that tablet for a while, because the procedure it describes has come down to us with a strange name, the substitute king. In the old language, Sharpuhi, the phrase itself is calm. The procedure it names is one of the strangest pieces of administration that has come out of any ancient state. Do not flinch from it. The men of this school did not. They wrote it down without drama, in the same hand they used for barley prices. It belongs in the long, calm record of how the world was, on this roof, in this city. Let us walk through it slowly. The school has the Enuma Anu Enlil on its shelves. We have already spoken of that text, 70 tablets, more than 1,000 years of compilation. Within those tablets there is a long, careful catalogue of celestial events and what each one means. Most of the meanings are general. A halo around the moon on a particular night of a particular month suggests perhaps abundant rain, or perhaps a shortage of grain in a distant province, or perhaps illness in the herds. The astronomers note the omens, the king's ministers consider them, and the world continues. A small number of celestial events, however, carry a heavier weight. They are read as omens of the death of the king. The most important of these is a lunar eclipse falling in particular months and on particular days. The Babylonian calendar, based on the actual visibility of each new moon, does not allow eclipses to happen on every kind of date. They cluster. A skilled astronomer of this school, looking ahead with the goal year texts and the standard cycles, can know months in advance which eclipses are coming, what their dates will be, and whether each of them will fall in a dangerous month. When one of those eclipses approaches, the chief astronomer takes the substitute king tablet down from its shelf. The procedure he prepares for is documented in many letters from earlier centuries, letters from astronomers of this same school and from a sister school further north, to kings of the Neo-Assyrian period. It is documented for the city of Babylon as well. By this Seleucid period, the practice has become less frequent, and its political meaning has shifted, but the school still preserves the procedure, and references to it still appear in the diary entries. So let us follow it the way a Babylonian scribe would have followed it, as a series of steps. Step 1. A lunar eclipse is foreseen for a dangerous month. The chief astronomer informs the palace, quietly, perhaps weeks ahead. Step 2. A man is chosen. He is not in any sense the modern listener will expect, a noble. He is not a relative. He is not a famous man. He is, by various accounts, a commoner, sometimes a prisoner, sometimes a gardener, sometimes a person whose station in life was already small. He is washed. He is fed well. He is dressed in royal garments. He is given the king's seal. He is enthroned. The real king, meanwhile, is taken aside dressed plainly, and instructed to behave as a farmer for the duration. He is called in the documents simply the farmer. Step 3. The bad omens. Every line of the eclipse, every sign that the heavens have offered, every implication drawn from the Enema Anu Enlil is written out in full on a tablet, not summarized, written out in full. This tablet is then read aloud to the substitute king and his substitute queen in the presence of the god Shamash, the cosmic judge, in his temple. The substitute is required to recite the omens after the priest. A legal transfer of fate is being witnessed. The omen is being moved from one body to another. Step 4. The substitute lives as king for a period of up to 100 days. He is fed, he is housed, he receives the deferences appropriate to his role. He is not asked to govern. There are letters preserved in which various astronomers, writing to the actual king during this period, refer matter-of-factly to the substitute as the king and to the actual king as the farmer. The court continues its work around the fiction. Step 5. After the 100 days, or whatever shorter period the chief astronomer decides is sufficient, the substitute is removed from his throne. The accounts of what happens at this point are kept brief in the documents. The phrase that recurs in various forms is that the substitute went to his fate and the omen was considered satisfied. The chief astronomer writes a final line on the tablet. The real king resumes his throne. The country, which during the substitute's 100 days has continued its ordinary work in a kind of quiet legal fiction, returns to its ordinary names. We should sit with the registers in which the documents speak of all of this. The letters from the school to the king during the substitute period are extraordinary precisely because they are unextraordinary. An astronomer writes to inform the king, addressed always as the farmer in code, of a small celestial event the previous night. He notes a halo around the moon. He notes the absence of any further bad omens. He notes that the substitute, addressed as the king, has performed his duties at a particular ritual that morning. He sends his usual respectful greeting. He signs his name. The form of the letter is the form of any other report. This flatness of register is in its own way the most striking thing about the procedure. The cosmos has, in this view, a court. The court has rules. The court can be answered with a procedure. The procedure is recorded in the school's archives, alongside the procedure for the new moon festival, the procedure for the king's accession rites, the procedure for purifying a temple after a flood. It is one procedure among many. It does not deserve a larger ink than the others. Now read all of that again gently, and notice the register. There is no drama in the school's account of this procedure. There is no horror in the language. There is no excitement. There is instead the steady prose of administrative documents. The substitute king is referred to, where he is referred to, as a person performing a particular ritual function. The bad omens are referred to as items to be transferred, the way one might transfer the contents of a ledger from one volume to another. The whole thing is, in the language of the temple, a quiet procedure. This is not because the men of this school did not understand what was being done. It is because they understood it as a procedure for the safety of the king, and through him, for the safety of the city. The cosmos had pronounced a sentence. The sentence had to land somewhere. The procedure caused it to land in a particular place, on a particular night, after a particular set of recitations witnessed by a particular god. The cosmos was a kind of court. The court had been answered. There is also a quiet temporal layer in the documents that is worth noticing. The substitute king ritual reaches its fullest documented form in the Neo-Assyrian period, several centuries before tonight. By the Seleucid period in which we are sitting, the procedure has become rarer. The kings of the Seleucid line are not Babylonians. They live elsewhere. They have their own ways of handling omens that come from outside the Babylonian tradition. The school of Isagila still keeps the tablet, still knows the steps, still trains its chief astronomer to recognize the eclipses that would have called for the procedure if a Babylonian-born king were on the throne. The tablet is in this sense partly archival, a piece of older institutional memory that the school has not let go of. The men of the school know that, in some sense, they may not perform the procedure again in their own working lives. They keep the knowledge anyway. They keep many such pieces of knowledge. This is part of what an old institution does. It holds the procedures it once needed, in case it needs them again. It teaches them to the next generation, not because the next generation will certainly use them, but because the next generation must know what the institution has known. The substitute king tablet sits on its shelf, the way a fire extinguisher sits in a modern hallway, not because the fire is expected, but because the institution has decided that the next person on duty should know how to reach for it without delay if the fire ever comes. That is a small modern image. Replace it gently with the older one, of a small clay slab on a quiet shelf, kept clean, kept in order, kept ready. We will not stay long with this. The astronomer's hand on the tablet tonight is calm. The chief astronomer is not on the roof. He is asleep, or in his reading room, or with his family. The substitute king tablet, if it is needed at all in the next year, will be needed for a lunar eclipse predicted 7 months from now. The young scribe at the parapet tonight has glanced over the procedure when his teacher reviewed it with him 3 years ago. He has not been involved. He may never be involved. He has instead his trapezoid and his market prices. What we are asked to feel by the school's own framing is something between a careful respect and a slow shrug. The procedure is rare. The procedure is real. The procedure is not the most important thing the school does. The most important thing the school does is the regular watching, the diaries, the trapezoids, the 12 boxes on the band of planets. The substitute king is a corner of the work, a small corner, and once the days had passed and the omen was considered satisfied, the lamp on that small tablet was set down, and the watch on the rooftop returned to its ordinary count of stars and prices and rivers. It is worth, at this point, returning to where we are. We are on a rooftop. The lamp is small. The brazier is warm at its center. The clay tablet on the bench has by now almost finished tonight's entry. The young scribe at the parapet is 23. The substitute king tablet is not in his hand. It is on a shelf 2 floors below, in a small room with a single low door. He has glanced at it before, when his teacher asked him to. He has not glanced at it tonight. He has been working on Jupiter, on the moon, on the haze on the eastern horizon, on the small remarks that go at the end of a calm diary entry. The procedure we have just walked through was, even at its busiest in older centuries, a thing that touched perhaps 2 or 3 nights of a man's working life. The rest of a working life was the diary entries, the trapezoids, the 12 boxes, the apprentices, the brazier, the lamp. Tonight is one of those many other nights. The procedure is, for this scribe, a piece of long memory rather than a piece of his evening. The night on this roof returns to the moon. The young scribe at the parapet writes a brief note about a faint star low in the south. He drinks a slow mouthful from the cup of warm infusion. He sets the cup down. He looks up. Long after the small tablet on the high shelf has been set down, the same school will look up on a different night and see something brighter and stranger than any eclipse, something that will return again, a lifetime later, to a different generation in the same room. The story does not end here. Long after this calm procedure, another kind of sight is recorded by the same hands. The middle watch is now well underway. The air on the rooftop has cooled. The lamp is steady. The young scribe at the parapet has refilled his cup from a small clay jar. His hands are warm from the brazier. The diary entry for tonight is mostly written. Only the prices section and a final line remain. On the bench beside him, the senior left a particular tablet before going down for sleep. The tablet is not a goal year text. It is not a market prices tablet. It is something the young scribe has been told to read tonight, slowly, if the watch is calm. The senior placed it just so, with a small folded square of linen, marking the line where he wants the young scribe to begin. The tablet is from the year that the young scribe's grandfather was a young man. It records a particular sight, written down by an earlier member of this same school, in the middle watch of a night perhaps 77 years ago. The entry describes a star that grew a tail. Let us sit with the entry the way the young scribe is sitting with it now. He reads it slowly, the way a scholar reads a passage he intends to remember. The cuneiform is older than tonight's hand, slightly squarer, slightly heavier, but the formulas are the same. There is a date, there is a position, there is a description. The star, the older entry says, appeared in the east, in the path of Anu, in the area of the Pleiades and Taurus. It moved across the sky in the following days. It passed along into the path of Ea. It had a tail. It was visible night after night. The young scribe looks up from the tablet toward the eastern horizon, as if to check. There is no comet there tonight. The eastern sky tonight holds Jupiter and a few quiet stars, and the haze that was thinning earlier has settled into a low band. He looks down again at the tablet. The star with the tail was recorded again by an even older scribe, 3 lifetimes before the senior's own grandfather, in a year that the young scribe is just learning to date from. That earlier entry is not on this particular tablet. It is on another, kept on a different shelf of the temple archive. The senior has mentioned it. The young scribe has not yet read it. He will in the next year or 2. What is on this particular tablet in his hands now, however, is the more recent of the 2 sightings. About 77 years ago, he runs his finger across the entry. very lightly so as not to mark it. The star with the tail came back. The same school saw it again. 2 human lifetimes apart. 1 comet. We now know in our own time what those 2 entries record. The bright body with the tail that appeared in the eastern sky of this city in 2 different years, once in the year that we now call 164 before Christ, and again about 77 years later in the year we now call 87 before Christ, is the same body. We call it Halley's Comet. It returns roughly every 76 years on a long elliptical orbit that swings it back through the inner solar system after a long absence in the cold dark beyond Jupiter. The 2 Babylonian records of it are the earliest precisely dated observations of any of Halley's returns. There are Chinese records of comets that may be Halley going further back, but the Babylonian tablets pinpoint the dates with a precision the older sources lack. 2 small clay tablets in the British Museum, catalogued in our time as numbers 41462 and 41018, hold the 2 sightings. They were re-identified in the early 1980s by scholars who looked carefully at the standard astronomical formulas and worked out what was being described. A paper announcing the find appeared in the journal Nature in 1985. 3 names appeared on it: Stevenson, Yao, and Hunger. The first 2 had read Chinese records of the same comet. The third was a specialist in Babylonian astronomy. Between them they had matched the entries to the orbit. There is a second tablet, much older, that records what we now call the same comet on a much earlier return. It is from the year that we now call 240 before Christ. That tablet is more fragmentary. Its date is less precisely fixed than the 2 later ones, but it shows that this school's nightly watch had already noticed the same bright body once before, in a generation much older than even the grandfather of the senior. The school's continuity stretches across the comet, not just from one return to the next, but from at least 3 returns. The comet, traveling its long quiet orbit, passes through the inner sky every 76 years. The school, going about its quiet nightly work, holds 3 returns in its archive. 2 are precisely dated. One is from before the standard formulas had fully settled and is more uncertain. The point is the same. The school has seen the same body more than once across generations of teachers. The young scribe at the parapet, of course, does not know any of this. He knows only that the senior placed this tablet beside him tonight and asked him to read it. He reads it again. He is silent for a long time. The sky overhead has not changed during his reading. The middle watch goes on. Jupiter has shifted slightly along the path of the planets. The moon is now lower. Somewhere over the dark river, a night bird makes a brief small sound and falls silent again. The young scribe sets the older tablet carefully back on the bench. He picks up his stylus. He returns to tonight's entry. He does not write anything special into tonight's entry about what he has just read. The procedure does not require him to. The older tablet will go back to its shelf in the morning. The senior, when he climbs back up at dawn, will ask whether he read it. The young scribe will say that he did. They will speak for a moment, perhaps, about how strange and quiet a thing it is to hold in one's hands the writing of a man one's own grandfather might have known by name. Then they will move on to the market prices. Let us hold the moment a little longer. The young scribe leans slightly closer to the lamp. The hand that wrote the older entry was the hand of a man named, well, the name is initialed at the bottom of the tablet in a small abbreviation that the young scribe can read. The initial belongs almost certainly to a man whose family was in this school for generations and whose grandson is now the senior who handed over at the beginning of the middle watch. The handwriting on the older entry is firm and square. The young scribe knows that handwriting. He has seen it on a dozen other tablets in the archive. He has, in fact, copied passages from those tablets when he was an apprentice. The hand has been a familiar companion for years. To see that familiar hand recording a star with a tail in the eastern sky on a particular night that the young scribe can now date gives the night a quiet density that is hard to describe. The hand of the older scribe is dead. The hand of the young scribe is here, on this bench tonight. Between the two of them, an institution. Between the two of them, a sky that does what it does, whether anyone is watching or not. And between the two of them, on this same shelf, several thousand other tablets, most of them only of the moon and Jupiter and the price of barley. This is the slow gift that comes from a school that has lasted for so long. The young scribe is not the first person to look at this tablet. His teacher was. His teacher's teacher was. The senior tonight read it in his own first watch as a young man, when an older senior placed it on the bench in front of him, and the older senior, in his own youth, had heard the story from his own teacher and read the same tablet from the same shelf. 3 or 4 generations of careful hands have passed it down across the room. The handwriting on the tablet does not change. The hands holding it do. It is also, when you sit with it, a small undoing of one of the modern world's quiet anxieties, the feeling that nothing made by human hand really lasts. Some things do. The lamp on the parapet does not. The bench does not. The young scribe will not. But the entry on the tablet, the small sentence about the star with the tail, written one ordinary night a lifetime and a half ago, has reached him. It has been read and is being read now by someone whose grandfather might have been a child the night it was first set down. It will be read again in 70 more years by someone who has not yet been born, and in a much further future, in a city that does not exist tonight, it will be read by men and women whose tools are made of metals nobody in Babylon knows the names of, and they will use it to chart the orbit of a comet that no one in this room has imagined as a thing in orbit at all. The star with the tail will come back again. The school will not be here to record it, but the entry will be. The scribe sets the tablet aside very carefully. He places his palm beside it on the bench for a moment, not on the clay itself, just beside it. The clay is cool under the lamp, with a faint warmth where the lamp has been closest. He breathes out. The lamp flame leans briefly away from the breath and steadies again. The breath is gone. The flame is gone. The lamp continues. A night bird somewhere along the dark river makes another small sound. Then silence again. The young scribe turns his face up toward the part of the sky in which the comet had been recorded. There is nothing bright there tonight. There are only the patient stars of the eastern Pleiades, faint and ordinary, and the faint band of haze along the horizon. He looks for a moment longer. He returns his eyes to the bench. He picks up his stylus to add one more line to tonight's entry. The young scribe runs his hand over the surface of the tablet one last time and lays it gently with its companions in the box at the corner of the bench. He has another half a watch to keep. He picks up his stylus, and as the tablet from a grandfather's year was set down beside tonight's, the watch continued, the way it had continued for the grandfather as well. Long after the comet had passed, the lamp burned on the parapet. Long after this watch ends, the lamp will burn there again. Long after, the middle watch is past its deepest point. The cold has settled. The river below is quieter than it has been all night. The boats tied up, the last late washing finished, the dogs along the bank lying down. The lamp on the parapet is the same lamp. The slab of clay on the bench is the same clay. The young scribe at the parapet has put the tablet of the older entry back into its box. He has tightened the linen at his shoulders against the cold. He has nothing more to write for the next quarter of an hour. He simply watches. The city below has shrunk. We should sit with that softly. Babylon in the late summer of 150 years before Christ is not the city it once was. The political world has gone elsewhere. The Seleucid kings who inherited this region from one of Alexander's generals have shifted much of the official life of the empire to a new capital further west, a city built on the Tigris and called Seleucia. Many of the old Babylonian merchants have moved there. Many of the old workshops have moved there. Some of the great houses of this city are now half empty. Streets that were narrow in living memory because of crowds are now narrow because of weeds, and yet the school is here. The school is still here. The rents from the date palm groves still come in. The tablets are still being added to the shelves. Apprentices are still arriving at the temple as small boys, learning their syllabary, beginning their long climb through the 70 tablets of Enuma Anu Enlil. Two of the most distinguished astronomers of recent generations are still spoken of in the school's halls as if their work has just been completed. Their names are Nabu-Rimanu and Kidinu. The young scribe at the parapet has of course heard those names. He has copied lines from their tablets. He could not perhaps give a clean account of which man worked on which system. He knows that one of them is associated with what later teachers came to call System A, the system that describes the speeds of the moon and planets as changing in clean steps. He knows that the other is associated with what later teachers came to call System B, the system that describes the same speeds as changing smoothly, up and down, in slow zigzag lines across the months. He knows that the lunar values that the school still uses, the values for the length of a month from one new moon to the next, are traced back to Kidinu, and that Kidinu's value is correct, by what modern atomic measurement can tell us, to within a couple of seconds, each month, worked out by a man who did not know what an atomic clock was, did not know what an atom was, did not know that the earth itself rotates, worked out from centuries of nightly diary entries on clay. The school does not boast of this. The young scribe does not boast of it either. He knows the value. He uses the value. He could not say which night Kedinu finished it. The value simply is. In the next room of the temple, on a different shelf, there are tablets in 2 languages. One of them is Babylonian, in cuneiform, written in the standard way. The other is Greek, the language of the Seleucid administration, the language of an increasing number of visitors who come from the new capital and from cities much further west. The Greek tablets are copies of the school's lunar and planetary computations, sometimes transliterated, sometimes translated. They were prepared in the previous generation, partly for traveling visitors. A few Greek-trained astronomers have come down the river to learn from this school. Some of them have stayed for a year. Some of them have left with notebooks of their own. One of them, perhaps a century from this present night, will become a teacher in his own right, in a city much further west, and his students will become teachers, and one of those students, generations and generations later, will be a young man in Alexandria named Claudius. We will know him as Ptolemy. He will write a textbook of astronomy that will dominate the educated world for 1400 years, and the tables in that textbook, the numerical values for the periods of the moon and the planets, will trace back by a chain of careful copyings to the very values the young scribe at this parapet now uses. We will not say that Ptolemy read these tablets. We do not know that he did. We will say only what we can say. The numbers, traced backward, lead here. There is a particular Greek visitor who came to this school perhaps 15 years ago. He stayed for a year. He had been sent down the river from Seleucia, the new capital, by a teacher there who had heard about the school's lunar tables and wanted his student to learn them at the source. The visitor was perhaps 30. He could read cuneiform after a fashion. He had brought his own wooden writing board with wax of a slightly different color than the local wax, and a metal stylus of a slightly different shape than the local stylus. He sat in the school's reading room every morning. The school's chief astronomer at the time, who was the present chief astronomer's predecessor, sat with him for an hour at a stretch and walked him through the tablets. The visitor took notes. He took copies. He left eventually with a small bundle of clay tablets that the school had allowed him to carry, and a larger bundle of wax tablet transcriptions. He returned by river to Seleucia. From Seleucia he traveled west eventually into territories the men of this school have not visited. He taught what he had learned to younger men in those territories. Some of his pupils traveled further west, to Alexandria and to other cities by other seas. They taught what they had learned to younger men in those further cities. The young scribe at the parapet does not know any of this either. He does not know that the values he writes tonight will outlive the language he writes in. He does not need to know. He simply writes. Look around the rooftop with him. The brazier glows. The lamp burns. The bench holds the clay. The box of older tablets sits at the corner. The night smells of dust from the parapet, and faintly of charcoal. The Euphrates is a thin band of darker dark beyond the western wall. Across the river, on the far bank, there is a small line of lights from a village. Behind us, somewhere down the temple stairs, The chief astronomer is asleep with his sandals still on. The senior, who handed over at the beginning of the middle watch, is also sleeping. They will rise before dawn. The city has shrunk. The school has not. There are quiet ways to see this. The chamber in which the apprentices learn their first cuneiform signs is the same chamber that was used for the same purpose 300 years ago. The mat on which the youngest of them sit is patched and old, but in the same place. The wall behind it is the same wall, the plaster repaired many times, the small painted band along its top renewed every few generations in the same blue-green pigment. The shelves on which the older tablets rest are not, of course, the original shelves. Wood does not last as long as fired clay, but the layout of the shelves is the same layout. The way the tablets are catalogued, by year, by king's regnal year, by month, is the same way. The cleaning of the room, the laying of new mats, the lighting of the lamps, the routine sounding of the temple gong at the end of each watch, all of this is in its broad outline what it was when the scribe's great-great-grandfather served his own first watch. The funding of the school is its own quiet story. The temple of Isagila owns groves of date palms along the river, in fields that have been temple property for many generations. The dates from those groves are harvested twice a year. They are sold partly to the city's markets, partly to traveling merchants who come down the river from Seleucia and back, partly to the temple's own bakers and brewers. The income from those sales flows into the temple's accounts. A portion of it pays the school, another portion pays the temple attendants, another portion goes into the upkeep of the buildings and into the rebuilding every few years of the parts that have fallen into disrepair. The school's officials know how much they need. They keep small ledgers of expected income and expected outgoings. The ledgers are themselves tablets, kept on a separate shelf in a separate room from the astronomical archive. The boy who fetches the prices for tonight's diary entry could also, if asked, fetch the ledger for last quarter's date grove income. He has not been asked. The ledger is calm in its drawer. This is the strange small gift of a long institution. Empires rise and fall around it. The price of barley triples and falls and rises again. The river runs higher in some decades than in others. New languages appear at the door, asking to be welcomed. Some of them stay, some of them go. The work continues. The watch continues. A boy is sat on the same mat as his great-great-grandfather was sat on, and is taught to draw the same wedges. He is taught patiently, the way the boys before him were taught patiently. He will, in his turn, become patient with the boys after him. The patience is the institution. The wedges are only the shape it takes on a particular clay slab on a particular evening. The same patience on a different night takes the shape of an entry for the price of barley. On another, the shape of a small trapezoid drawn on wax. On another, the shape of a comet seen in the east at the changing of the watches. The young scribe at the parapet breathes out. The breath shows faintly in the cold air. He picks up his stylus. He writes the last line of tonight's entry, a small remark about the haze on the eastern horizon. He puts the stylus down. He sets the linen folded square neatly to the side of the tablet, so that the clay can finish drying without anything resting on it. In the morning, The senior will collect this tablet and another. He will look it over briefly. He will nod. He will hand it to a junior, who will store it on the appropriate shelf, behind several centuries of others. There the tablet will sit. Cities and empires will pass through this country. The Seleucids will fade. The Parthians will arrive. Eventually, much later, a different language will replace Greek, and a different replace that, and the temple itself will fall into disuse, and after long years its stones will be carried away to build other walls in other towns, and the tablets will still be there, buried under what was once a roof, waiting for hands that have not yet been born. And as the last of the second watch slips into the third, the city below has finished its long settling. Now imagine the smallest sounds of all. The third watch has come. The middle watch scribe, the young one, has been replaced by another, almost as young. The changeover at the parapet was as quiet as the one before it. A nod, a word about the moon, which has now sunk past the western horizon. A word about Jupiter, which is high. A word about the haze, which has dropped into a thin band along the eastern edge. Then the young one went down. The new one settled at the bench. We stay on the roof. The lamp is still burning. The flame is small and steady. The oil in the dish has gone down by perhaps a third since the beginning of the night. The bench still holds the clay tablet, almost finished, drying. The wax tablet rests beside it, blank again. The folded linen has been replaced by a fresh one. The cup of warm infusion is no longer warm. The third watch scribe has set it aside without drinking. Below us, the city has gone quiet in a deeper way than before. Earlier, when we first arrived on this roof, the street still carried the soft sounds of a city closing down. A final voice, a closing door, a dog. Now none of those things. The streets are silent. The river is silent. The far bank is silent. Even the brazier on the parapet has dimmed to a slow red glow under a thin layer of ash. The air is at its coldest. The middle watch's coldest hour has passed. The third watch's coldness is gentler, drier, the kind of cold that you stop feeling after a while. Sit with us in the cold. The cold of the third watch is gentler than the cold of the middle watch. It is the kind of cold that has settled in for so long that the body no longer protests against it. The body has adjusted. The blood has adjusted. The hands at the parapet are working at a slower pace and feel only slightly less than they did an hour ago. The toes inside the leather sandals have grown used to their stiffness. The shoulders have dropped into the cloak. The breath comes more slowly. One the watt. The lamp on its stone is the same lamp. The brazier in its corner is the same brazier. The parapet under the resting forearms is the same parapet. The river below is the same river. It has not risen. It has not fallen. It is moving at its own slow pace, the way it moves through every night of the year, neither in a hurry nor in any way reluctant. The sky overhead has rotated very gently in the time we have been here. Stars that were near the horizon when we arrived are now high. Stars that were high are now beginning to lean toward the western horizon. The whole vault has done its quiet quarter turn as it does every 6 hours, as it has done every 6 hours for as long as there has been anyone to notice. The new scribe at the parapet has done very little. He has checked Jupiter's position once. He has noted on the wax tablet, in a single short line of arithmetic, that Jupiter is on the line the school expected. He has set the stylus down. He has put a small handful of charcoal into the brazier. He has watched the first thin orange catch and brighten and settle. Let us stay with the brazier for a moment. The glow on its surface is the same kind of glow as the lamp. It comes from the same kind of fire that the apprentice who came up before him laid down here at the changing of the previous watch, and from the same kind of fire that has been laid on this rooftop in some form for almost 600 years of nights. A handful of charcoal, a small breath of wind across it, the faint orange of small embers. The lamp is the same, the parapet is the same, the river below is the same river. The water tonight is 2.5 cubits high at the temple's water gate. Tomorrow night it will be 2.5 cubits high again, give or take a hand's breadth. The school will note both readings. The lamp is the same lamp that was here at the beginning of the night. The oil in it has gone down a little. The wick has been trimmed once. Otherwise nothing about it has changed. It is small and small and small. The brazier is the same brazier. The handful of charcoal that the scribe added a few moments ago has caught and settled. The new coals lie on top of the old coals. Beneath them, the ash is deepening. The orange under the ash is steady. A small flake of ash drifts up, very briefly, and disappears. The parapet is the same parapet, smooth by the elbows of generations. The river is the same river, moving without urgency, the dark band of it widening and narrowing along the city wall depending on the moon's light, which is no longer in the sky tonight. The sky moves, slowly, very slowly, from the point of view of someone watching. The brightest star near Jupiter's path has shifted, in the time since we arrived, by perhaps the width of 3 or 4 fingers held at arm's length. Jupiter itself has shifted slightly less. The whole vault of the sky has rotated overhead by a quiet quarter turn. The man at the parapet does not need to look up to know it. He can feel it the way a fisherman feels the slow change of a tide without checking. He is, in fact, not looking up now. He is looking down at the wood of the bench. He has put his stylus into a small wooden tray. He has set his hand flat on the bench, palm down. He is letting the wood take the cold out of his palm. The night has a long way to go, but tonight's work is mostly done. The diary entry is written, the prices are recorded, the river is recorded, the weather is recorded, the crossings of the moon and Jupiter are recorded. The position of Venus before its set is recorded. Tonight on this tablet, there has been no eclipse to note. There has been no comet, no halo, no meteor. The line at the bottom of the tablet, the line for unusual events, is blank. That is itself a kind of entry, calm. There is a particular quality to the third watch sky that the school's older scribes have written about, from time to time, in personal letters rather than in the diaries. The diaries do not record feeling. The letters do sometimes. The quality they describe is a stillness that is hard to put into language. The stars do not look brighter than usual. They look more patient. They look, somehow, as if they have decided to stay. It is a feeling rather than an observation. The men of this school have written, from time to time, that this is their favorite part of the night. The new scribe at the parapet would, if asked, agree. He would not say much. He would nod. He would say, perhaps, that the third watch is good. He would offer no more. Far below, in narrow streets, the people of the city are asleep. In the temple courtyard, behind us and below us, the night attendants are asleep at their posts, their lamps trimmed low. In the small room 1 floor down, the senior is asleep, breathing slowly. The young scribe, who was at this parapet during the middle watch, is asleep too, on a thin mat, with the smell of charcoal still in his hair. In a smaller chamber across the courtyard, the chief astronomer is asleep. So are his wife and his 2 grown sons. So are the boy apprentices, in their own dormitory, lined up on their mats, in the order of seniority. The temple breathes slowly. The river breathes slowly. We breathe slowly. We breathe slowly. Let the breath move down into your chest, and then further into the slow place that lies below the chest. Let the shoulders fall a little more. Let the lamp in your room, if there is one, sit lower than before. Whatever was on your mind earlier in the evening has had its turn. It does not need another. The stylus is in its tray. The hand on the bench is warm now. The clay tablet is drying in the still air. The brazier glows. The lamp burns. The river is dark. The sky is moving without hurry. Let the rooftop hold you for a while. The parapet is wide enough to lean on. The bench is steady under the clay. The lamp does not flicker. The brazier does not need attention. The river does not need attention. The sky does not need attention. Everything that needs to be tended in this small, calm world is being tended. Let your eyes soften. Let your face soften. Let your jaw soften. Let your shoulders soften further than they have softened. Let the cloak, if you are imagining one, sit more lightly on you. Let the cold of the rooftop be a gentle far-off cold, rather than a near one. The man at the parapet stays where he is. He has nothing he needs to do for the next quarter of an hour. He will have nothing he needs to do for the quarter of an hour after that. He will, perhaps, get up once before dawn and look at the eastern horizon to see whether the haze has cleared. If it has, he will make a small note. If it has not, he will make a different small note. Either way, the night will end calmly. The sky overhead is at its quietest. The stars are most patient now. They will not change their pattern in any way the man at the parapet can perceive until the very first pale band appears in the east. Then he will know that the third watch is closing. The senior will rise. The chief astronomer will rise. The apprentices will rise. The city will begin, softly, to wake. We will not stay for that. We will leave the man at the parapet to his last hour. We will leave the lamp burning. We will leave the river dark. We will leave the city sleeping. We will leave the brazier with its faint orange under thin ash. We will leave the stylus in its tray. We will leave the clay tablet, almost dry now, set beside the folded linen square at the corner of the bench. We will leave the small wooden box of older tablets in its place against the parapet wall. We will leave the third watch to do what the third watch does, which is mostly to wait quietly until the eastern horizon begins to pale. Let the rooftops settle in your mind, the flat warm stone, the small lamp, the reed pen in its tray, the clay tablet drying, the brazier with its faint orange, the parapet wall, the night air, and so as the rooftop settles, and the city below is fully asleep, only the sky still moves, and even the sky is in no hurry. We will leave the rooftop now, softly. Let the picture stay with you for a while longer. The slab of damp clay on the bench, almost finished, drying in the still air, the reed stylus in its small wooden tray, the lamp burning low and steady, the brazier with its faint orange under thin ash, the wax tablet, blank again, ready for whoever sits here tomorrow night. Below the parapet, the dark band of the Euphrates, beyond the river, the small line of lights from the far village, fewer than before. Behind us, the long shape of the temple, its rooms quiet. In one of those rooms, the senior is asleep. In another, the chief astronomer is asleep with his family. In another, the boy apprentices are lined up on their mats. Let your shoulders fall a little more. Think of the tablet drying. 6 commodities, 6 centuries of nights. The barley and the moon on the same line, the river height, the weather, the small remark about the eastern haze, all of it set down without urgency by a hand that did not need to rush. Think of the 12 quiet boxes drawn across the band of stars, the hired man, the bull, the twins, the names familiar in their later forms, the grid that came from this city, made portable across centuries, made personal by other peoples, made known to you gently tonight. Think of the 3 watches, the first, the middle, the third, the handover at the parapet with its few quiet words, the brazier tended, the lamp tended, the night divided so the sky would never be unwatched. Think of the trapezoid, the small 4-sided figure drawn on wax, its area giving the distance of Jupiter, a picture in a space that does not exist anywhere except in the mind, the kind of picture that would not be drawn again in any documented form for 1400 more years, drawn here calmly by a hand that did not think it was doing anything remarkable. Think of the small tablet kept apart on its shelf, the quiet procedure, the substitute, the recitation, the omen considered satisfied, the 100 days, the return of the king to his throne, the closing of the tablet, the lamp set down, calm, in the school's own register, a corner of the work, a small corner. Think of the older entry from a grandfather's year, the star with the tail, in the east, in the path of Anu, near the Pleiades. Read again, on a quiet night, by a young scribe of the same school, held in the hand the way one holds a letter from someone one has not met. The same comet would come back. The school would not. The entry has. Think of the school itself, the mats in the classroom, patched and old. The painted band on the wall renewed every few generations in the same blue-green. The shelves of older tablets, rents from date palm groves keeping the lamps lit. The names of Nabu-Rimanu and Kidinu spoken without fanfare. The numbers traced backward through centuries, leading here. Think of the third watch, going on now in its own quiet way. The man at the parapet, his hand flat on the bench, the stylus in its tray, the clay drying, the river dark, the lamp burning, the sky in no hurry. All of this set down on a single ordinary night in a city that was already old. Now let it begin to fade. Let the lamp grow softer. Let the river slow. Let the rooftop become a feeling rather than a place. Let the names go. Let the watch end. Close your eyes. Breathe slowly. Let your body soften. Let the lamp drift. Nothing more to hold. Nothing more to follow. Sleep well.